Hello all, welcome to the session. In this session, we'll discuss about the summary of object-oriented programming concepts. The main idea behind object-oriented programming is that instead of thinking only in terms of a sequence of functions or instructions, we organize a program around objects. An object represents an entity that contains both data and operations that can be performed on the data. In object-oriented programming, we try to represent such entities using classes and objects. C++ is particularly suitable for object-oriented programming because it provides a high-level object-oriented features while still giving the programmer considerable control over memory and system-level operations. So C++ is widely used in areas such as system software, embedded applications, game engines, and many performance-sensitive applications. So C++ gives us an interesting combination abstraction and object-oriented programming along with low-level control and performance. Here are the four pillars of object-oriented programming. So encapsulation followed by abstraction, inheritance and polymorphism. Let us understand each one briefly. First is encapsulation. Encapsulation means bundling of the data and function that operate on the data together inside a class while controlling access to the internal data. Second is abstraction. Abstraction means exposing only the important information to the user while hiding unnecessary implementation details. Next is inheritance. Inheritance allows us to create a new class based on the existing class. The new class can reuse and extend the properties and behaviors of the existing class. Finally, we have polymorphism. Poly literally means many forms. The same interface or operation can behave differently depending on the situation. These four concepts work together to make object-oriented program easier to organize, reuse, and maintain. So now let's begin with the basic building blocks of object-oriented programming, that is classes and objects. A class can be considered a blueprint. For example, imagine a blueprint for constructing a house. The blueprint describes what the house should contain, but the blueprint itself is not the actual house. Similarly, a C++ class describes data members and member functions that its object will have. So consider a simple class called car. We can have data members such as brand and year as shown in this example. So we can also define a member function called honk. At this stage, merely defining the class does not create an actual car object in the memory. We have only created the blueprint. Now, inside the main function, we will create an object called myCar for the class car. So we can assign brand such as Toyota to the brand the myCar and year of make is 2024 for the object called myCar. So we can assign brands and then call honk function also. So when we create car my car in this line, my car becomes the actual object or instance of the car class. We can then access its members using the dot operator as shown here. My car dot brand, my car dot year, my car dot honk. The output will display the brand and the message generated by the honk function. So remember the simple distinction. Class is blueprint. Object is the actual instance created from the blueprint. Now let's look at another important concept in classes, that is access specifiers. C++ provides three major access specifiers: public, private, and protected. When a member is declared public, it can generally be accessed from outside the class through an object. When a member is declared as private, it can be accessed only from within the class itself. In fact, for a class, private is the default access level. The third access specifier is protected. Protected members are similar to private members in terms of outside access, but they can also be accessed by the derived classes. This becomes particularly important when we study inheritance concept. For example, suppose an account class contains a private data member called balance. If we try to directly access balance through an object from outside the class, the compiler generates an error because the member is private. This is one of the mechanisms through which C++ provides data protection and encapsulation. So let's connect this with encapsulation. Encapsulation means the data and operations associated with that data are kept together while direct access to internal state can be restricted. This provides three major benefits. First is safety. We can prevent invalid values from being directly assigned to the internal data. Second is control. Instead of allowing anyone to modify the data directly, we can force modifications through carefully designed member functions. Third is flexibility. The internal implementation of a class can change without necessarily affecting the code that uses the class. Now, abstraction is related, but it is not exactly the same. Abstraction focuses on hiding unnecessary complexity. For example, when you press the brake pedal in car, you know that operation you want to perform. You want the vehicle to slow down or stop. You do not need to know all the internal hydraulic or electronic mechanisms involved. So we can remember in this way. Encapsulation primarily hides and protects data, whereas abstraction hides implementation and complexity. Both concepts work together in object-oriented programming. Here is the major topic of this lecture, that is inheritance. Inheritance allows one class to acquire properties and behaviors from another class. The existing class is called the base class or the parent class. The new class is called the derived class or the child class. The relationship is generally described as is a relationship. For example, dog is an animal, a car is a vehicle, a student is a person. So, if we have a class called animal, we can create another class called dog that inherits that animal. The dog can reuse common features provided by animals and can additionally refine its own features. Inheritance therefore provides code reuse, extensibility, and hierarchical modeling. Here comes the various types of inheritance in C++. C++ supports several forms of inheritance. The major types shown in our material are single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and hybrid inheritance. As in single inheritance, one base class has one derived class. In multi-level inheritance, a class forms a chain from A to B, B to C. In multiple inheritance, one derived class inherits from two or more base classes. In hierarchical inheritance, several derived classes inherit from the same base classes. The hybrid inheritance is a combination of two or more inheritance types. So let's understand about these types of inheritance one by one in the next video. Thanks for watching.